Welcome to this explainer where we're going to dive right below the surface of the seemingly weightless cloud to uncover the massive physical footprint of artificial intelligence. We tend to think of the digital world as existing in some invisible, ethereal space. But the reality? Every prompt you type, every video you stream, and every single AI model we train has a very tangible, heavy anchor in the physical world. Today, we're going completely under the radar to look at the real-world resources that actually make our digital lives possible. So, this brings up a genuinely fascinating question that completely flips our assumptions about digital efficiency right on its head. Think about it. If AI is making us so incredibly efficient, why in the world is it consuming more resources than ever before? We constantly hear about how smart algorithms are optimizing our power grids, streamlining our logistics, and reducing waste. Logically, you'd think this means we're using fewer resources overall, right? Well, the data tells a vastly different and, honestly, somewhat counterintuitive story. Section 1. The AI Efficiency Paradox. To figure that out, we first have to explore the very top layer of our iceberg, something called the Jevons paradox. This was actually originally identified by William Stanley Jevons back in the 19th century when he was looking at coal use. And it explains how making a process more efficient actually encourages us to consume significantly more of it. Think about it like this. When AI makes a task cheaper and faster, the cost of operating drops. Because it's suddenly so much cheaper and far more capable, businesses and everyday consumers naturally just use that technology way more frequently. So instead of saving energy overall, those per-unit savings just lead to a massive surge in total usage. This is known as the rebound effect, and it can literally negate the environmental benefits we expect to get from AI. And we are seeing this paradigm shift happen across practically every industry right now. Take transportation, for example. AI routing, like UPS's Orion system, saved over 10 million gallons of fuel. Huge win, right? But as driving becomes more autonomous and cheaper, vehicle usage actually expands, which potentially increases total emissions. In manufacturing, AI predictive maintenance reduces downtime and energy waste per unit. Yet those lower production costs just tempt companies to scale up their production to meet consumer demand, consuming more overall resources in the end. And in data centers? Well, Google's DeepMind AI actually reduced cooling energy usage by a staggering 40%. But the cheaper operational costs just led to an absolutely massive expansion of data services and complex computations globally. Basically, efficiency breeds demand. Section 2. The massive water footprint. All right, as we plunge a bit deeper below the surface, past the energy paradox, we hit a truly stunning physical reality. 228 billion. That is the staggering number of gallons of water consumed by U.S. data centers in 2023 alone. To put that massive figure into perspective, that is enough water to cover the needs of 788 million people. As servers process the super heavy computations required by AI, they generate an enormous amount of heat. So, to prevent catastrophic meltdowns, these facilities rely on evaporative cooling. Basically, they use precious water to absorb the heat and release it as vapor. Now, you might be thinking all that water is just flowing straight into the server buildings. Well, actually, a massive 75% of a data center's water footprint is completely indirect. This indirect water is consumed completely off-site, used merely to generate the electricity, often at thermal and nuclear power plants, that powers those servers. Only about 25% is direct water consumption used for on-site cooling. This means that even a data center claiming to be low water use on site still has a massive invisible water footprint deeply connected to its power grid. If this growth continues unchecked, guys, we are looking at an astonishing 450 million gallons of fresh water being consumed every single day by 2030. That is the equivalent of 681 Olympic-sized swimming pools of water evaporating into thin air every 24 hours just to keep the world's digital infrastructure running. And this is happening precisely as climate change is increasing drought frequency worldwide. Section 3. Real-world resource clashes. So what does this actually look like on the ground? Well, the infinite ambition of the digital cloud is aggressively colliding with actual human communities fighting for survival in water-stressed regions. Let's look at Spain first. In the Aragon region, which is an area where 75% of the country is at risk of desertification, Amazon data centers are licensed to use over 750,000 cubic meters of water a year. That is water directly competing with local cornfields. Meanwhile, over in the U.S., look at Maricopa County, Arizona. Google's Mesa facility has a permit to use 5.5 million cubic meters of water a year, which is equivalent to the usage of 23,000 local residents. This is happening in a county that literally had to halt new home building because of severe groundwater shortages. Digital infrastructure is directly, physically competing with drinking water and agriculture. Section 4. Hidden chemical and safety risks. When communities predictably push back against this massive water use, data centers often turn to private wastewater treatment and water recycling. And hey, the EPA actually encourages the use of recycled water for data centers through its Water Reuse Action Plan. But here's the catch. While reusing water sounds wonderfully green on paper, in reality, it creates a highly toxic chemical soup. You see, continuously reusing water in cooling systems causes contaminants become heavily concentrated over time. To manage this, facilities have to pump in harsh chemical additives. We're talking chlorine-based disinfectants, acids for pH adjustment, and coagulants. This means the ethereal, automated AI cloud is actually being maintained by physical human workers who are handling dangerous industrial chemicals day in, day out. Because of this pretty toxic reality, adopting voluntary water recycling triggers some incredibly strict, mandatory OSHA safety obligations. Data centers have to implement a strict hazard communication program. If they use large enough quantities of these chemicals, they trigger process safety management protocols. And most visibly, this forces human technicians to don serious personal protective equipment. We are talking chemical-resistant gloves, safety goggles, face shields, and full-on respirators. The price of our seamless AI interactions is human workers suited up in hazmat-style gear just to keep the servers cool and safe. Section 5. Engineering a sustainable future. Okay, so how do we actually navigate out of these unseen depths? We've seen the paradoxes, the water depletion, and the hazardous working conditions. Mitigation definitely requires a multi-pronged approach. First up, corporate pledges. Tech giants like Amazon and Microsoft are committing to become water positive by 2030, meaning they aim to restore more water to the environment than they consume. Second, we're seeing a shift in engineering toward green data centers utilizing liquid-free cooling, closed-loop water systems, and AI-driven thermal optimization. Third, to address that rebound effect we talked about earlier, we need regulatory frameworks like usage caps and tiered pricing. And finally, the industry has to rigorously measure not just power usage effectiveness, but water usage effectiveness. It's really all about designing infrastructure that is both low carbon and low water. It all boils down to this really profound realization. The digital world might feel completely weightless, but it rests on a very real and a very fragile resource. Our digital habits, our love for instant AI generation, and our endless data storage, they all have a heavy, tangible cost on our physical environment and the people who maintain it. We simply cannot let the illusion of the cloud distract us from the reality of the ground. So the next time you fire up a new AI tool or stream a video, I want you to consider this final thought. How on earth can we balance the limitless potential of AI with the very finite resources of our planet? If data is everything in the modern world, water and a safe environment remain the absolute lifeblood of our physical one. Protecting our technological future must never come at the cost of our planetary present. Thank you so much for joining me on this deep dive. Stay curious and always keep looking beneath the surface.